Malaria indeed is Africa's biggest child killer. Malaria kills over 1 million people and up to 500 million clinical cases every year. About 90% of the deaths occur in Africa, where most are children under 5. According to the latest World Health Organization's annual report, released in December 2013, there were about 207 million cases of malaria and an estimated 627,000 malaria deaths worldwide in 2012. Though malaria was contained in the 1940s and 1950s, as the Western world was interested enough at that time to weed out the disease, it recently struck the world without warning once more. Since 2006, the WHO endorsed the DDT pesticide to fight malaria and filaria. But this chemical weapon has its own negative health implications on humans. Only one researcher with his team from the GUC managed to put an end once and for all to one of Africa's most deadly diseases. According to the latest World Health Organization's reports, malaria is a major life-threatening disease for more than 3.3 billion people, roughly half of the world's population. This disease continues spreading over 106 countries worldwide. Malaria remains one of the major causes of poverty and underdevelopment, and one of the main obstacles in the face of economic growth. Dr. Mahmoud Hashim Abdel Qadir, the GUC president and photochemistry expert, adopted an effective, efficient, and environmentally friendly technique by using sunlight to annihilate the female mosquito-borne infectious diseases. This innovative breakthrough relies on photodynamic modalities, using direct sunlight along with photoactive compounds, photosensitizers. These compounds are environmentally friendly substances extracted from natural plants cultivated either in Egypt or any similar environment. For example, the hyacinth plant and the extracted compounds are called chlorophyll derivatives. Apart from using the chemical pesticides, these substances are natural and safe for both humans and animals. They are even environmentally friendly and don't have an adverse environmental impact. These substances also have been officially approved by the Food and Drug Administration as food coloring or dietary supplements. This innovative technique depends on spraying naturally extracted chlorophyll derivatives on swamps infected with borne disease Anopheles mosquito larvae. The mosquito larvae feed on plant extract, so these substances enter their bodies accordingly, where the chlorophyll derivatives accumulate inside the Anopheles mosquito larvae's bodies and absorb solar energy, converting it into chemical energy. This chemical energy is transferred to the oxygen existing in the living cells of the Anopheles mosquito larva, resulting in reactive oxygen species, ROS. In other words, a photochemical reaction takes place, which converts sunlight into chemical energy, resulting in reactive oxygen species. The latter are toxic and harmful to Anopheles mosquito larva's tissues, oxidative stress, and consequently, these cells and tissues will be completely destroyed. Eventually, the Anopheles mosquito larva will be killed. Through this process, the Anopheles mosquito larva's life cycle, which causes malaria, will be successfully interrupted. Dr. Tariq Tayyib, one member of the creative research team, and whom his master's thesis was supervised by Dr. Mahmoud, managed to achieve impressive results pertinent to fighting the Anopheles mosquito larva which cause malaria.
The Anopheles mosquito carrying malaria was the topic of my master thesis. The giving of my thesis was about destroying the vector causing disease transmission from human to another. The Anopheles mosquito lives among humans, and a part of its life cycle is in the water which is used by humans, animals, and fish. Therefore, the difficulty lied in choosing a photosynthesizing material that is environmentally friendly with no harmful effect on humans, animals, plants, and any living organism in the same environment. Also, we wanted to specifically target the mosquito without harming any other biological beneficiary organisms living in the same environment.
Dr. Mahmoud, together with his scientific research team, applied successfully his innovative technique in 3 African countries: Ethiopia, Sudan, and Uganda.
أثناء زيارتي لدول حوض النيل وبالذات أوغندا في سنة 2011.
During my visit to the Nile River Basin countries, in Uganda in 2011, I met with His Excellency President Museveni of Uganda.
ووجدته إنه بيعلم عن المشروع المصري الذي
Surprisingly enough, I found out that President Museveni knows a lot about the Egyptian project carried out there by non-governmental efforts, specifically from the Egyptian company INRAD, Innovative Research and Development Company. He explicitly said, "I will eradicate malaria using the Egyptian project."
We worked in Uganda, Ethiopia, and South Sudan, and we have formed memoranda of understanding with these countries. Also, we went to Burundi and Kenya in order to present this project later on as a complete Egyptian project for these countries. The project was considered among the Egyptian initiatives towards Nile Basin countries to help the African countries eradicate malaria disease.
Local and regional media outlets hailed Dr. Mahmoud's achievement in stamping out malaria disease.
We achieved significant progress in Egypt pertinent to this field. We spare no effort to help the African countries eradicating this disease.
Malaria is one of Africa's most deadly diseases. All African governments have to be aware of its gravity. We also hope to apply this innovative breakthrough in our country soon. This scientific project is going to protect and enhance the environment, in addition to eradicating malaria. We'll provide the Egyptian research team with all the needed facilities to apply this technique in our country and protect our people from diseases.
For its part, the Journal of American Society for Photobiology, ASP, in 2013 heaped praise to this new scientific breakthrough aiming at eradicating malaria.
الجدير بالذكر طبعا دور الجامعة الألمانية هنا في القاهرة.
Since the foundation of the GUC and being its president in 2002, the GUC took upon its shoulders the effective role of serving the community at large. The university carried out and supported many researches pertinent to malaria on and off campus. Even the master's and PhD students in the field obtained their degrees in collaboration with the GUC and National Institute of Laser Enhanced Sciences at Cairo University. One should mention the impressive role of the GUC, which was keen first and foremost to cooperate with the African countries. In this context, many agreements have been signed with Egypt's Foreign Affairs Ministry. GUC's postgraduate studies and scientific research faculty used to accept African students from the Nile River Basin countries to enroll in the university's different majors. Those students even got full tuition fee waiver scholarships. For more than 40 years of meaningful scientific research dealing with the ills of the Egyptian society, the World Intellectual Property Organization, WIPO, in addition to Egypt's Academy of Scientific Research, awarded Dr. Mahmoud Hashim 8 patents. These patents were granted for more than 100 international researchers and unique efforts poured into solving Egypt's and Africa's chronic problems in fields of health, food, and environment. Additionally, Dr. Mahmoud was honored several times in local and international ceremonies. The GUC, represented in its president and top-notch researchers, will always contribute to finding solutions to incurable diseases plaguing the society, and will always stand above the crowd.